Okay, let's take a look at these review questions here. So, question number one says explain why ionic compounds do not conduct electricity in the crystalline form. So, if you remember from the notes, an electric current requires two things. One, you need charged particles, and two, they have to be able to move. So, an ionic compound does have charged particles. So, by definition, it's made up of cations and anions, positive and negative charges. But the problem in the crystalline form is that it doesn't meet qualification number two. Those ions cannot move, so they're stuck. The electrostatic force of attraction binds them together in a solid form. So the cations and anions can't move together. So number two, why do metals and nonmetals usually form ionic compounds, whereas two bonded nonmetals are never ionic? So this has to do with the very basic definition of the formation of an ionic compound. This is the difference in electronegativity. Metals and nonmetals have very different electronegativity values. So it's large enough for the nonmetal to be able to fully rip away the electron from the metal, whereas two bonded nonmetals are too similar in electronegativity. Number three, why do ionic compounds tend to be hard? So they're hard due to the force of electrostatic attraction. That electrostatic attraction is extremely strong. So it's very difficult to dislodge the ions from one another. Number four, describe whether the following compounds are likely to be ionic or not based on the properties. So we have compound number one here. So it says compound one has a melting point of 554 Celsius and dissolves well in water. So has a very high melting point, it's high temperature, and it's also soluble in water. So we know it's a polar substance. So it meets both qualification. Both those are qualifications for an ionic substance. So if it was covalent, you could say it's sugar. It would also dissolve in water, but sugar has a very low melting point. So you can put it into under a pan or whatever, and it melts far 100 degrees or less than 100 degrees Celsius. So it's far lower. Compound two is brittle. So brittle, that's our keyword. Remember, that's one of our vocab terms. So brittle means it is ionic. Compound three melts at 85 Celsius and catches fire when heated to 570. So here it melts at a very low temperature. So this is a non-ionic substance. Number five, write out the valence electrons from each of the main groups. So we go over to our periodic table. Remember, the main groups are 1, 2, 13 through 18. So valence electron numbers. So remember, the valence electron numbers are simply the same as the numbered columns. So your main group elements are designated with the A. The other elements, so remember, we kind of ignore the transition elements down here. There, notice that we have column B being used instead of A. So valence electrons 1, 2, 3, 4, 5, 6, 7, and 8. Okay, number 6. So how many electrons does phosphorus have to gain in order to achieve a noble gas configuration? So if we look for phosphorus, we see it is in group 5A, so it already has 5 valence electrons. It means to get to the stable S and P sublevels, we need 3 more, so it has to gain 3 electrons. 7, how many valence electrons are transferred to nitrogen from each potassium in the formation of potassium nitride? So what is the formula for potassium nitride? So here we're dealing with potassium, which is in group 1, so it has 1 valence electron. And nitrogen is in group, again, 5A there, so it has 5. That means nitrogen needs to gain 3 valence electrons. However, potassium has only 1 to give, so it can only transfer a single valence electron over. That means in order to have nitrogen reach a stable octet, it needs 3 different potassium atoms there. Number 8, which of the following takes place in an ionic bond? So again, definition of ionic bond is electrons are transferred from the metal to the non-metal in order to achieve a stable octet. So 2 atoms share electrons. That's not an ionic bond. There's no sharing. 2 atoms share electrons that both follow the octet rule. Again, we're not sharing. Like charged ions attract. Nope, like charged ions repel. Oppositely charged ions attract. So number 9, what is the net charge of the ionic compound calcium fluoride? Net charge. So the net charge of all ionic compounds is 0. So this is why they will form. So they'll keep sticking to each other until the positive and the negative charges balance out. So it's 0. Number 10, ionic compounds are normally found in what state? Because ionic compounds consist of a very strong electrostatic attraction, it takes a lot of energy to break them apart. Ionic compounds are always solid at room temperature. 11, the melting temperature of potassium chloride. So here we have a substance made up of a metal and a non-metal. So we have potassium and chlorine. So notice they're on opposite sides of the periodic table. So we have a big gap there, meaning there's a big gap in electronegativity. So we're going to get an ionic compound. That means this is ionic. It's going to have a very high melting point. An anion is an ion with a negative charge. Cation, on the other hand, is a positive charge. Most stable ions have an electron configuration similar to that of a noble gas. So ions will end up with a full S and P sublevel. That's what you have in group 18 there. 15, the attractive force between sodium and chloride results in an arrangement of ions in repeating units arranged to form a crystal lattice. So the repeating unit itself is the unit cell, and then we stack those unit cells together to get the crystal lattice structure. 16, 1 mole of a salt is formed from gaseous ions. Lattice energy is released. So that's just definition there. It's a lattice energy. So the energy that's released when an ionic compound, when the crystal lattice forms, is the lattice energy. 17, the specific way in which atoms are arranged in an ionic compound is called the unit cell. Okay. The unit cell makes up the crystal lattice. 18, an ion that has a similar electron configuration to that of neon. So if we look at neon here, neon has 10 electrons on it. So we want to find an ion that also has 10 electrons. So we can look at chlorine. So chlorine is in group 17, so that means that it's going to gain 1 electron. It has 7, it needs to get to 8, so it's going to gain 1. It starts with 17. If it gains 1, it gets 18. So that's not the answer. Sodium. Sodium is all the way over here. It's group 1A. So sodium will lose 1 electron. It's a metal. So it starts with 11, but it loses 1, so it ends up with 10 electrons. So there's your answer. Chlorine or a sodium ion will also have 10 electrons. Sodium atom itself, we just saw is 11. This didn't do anything. See, there's no charge here. And oxygen will gain 2 electrons. So oxygen gained 2 electrons, but we see here that in this sheet it's just a negative. So that's not actually the correct formula for an oxygen ion. So oxygen is really, since it's in group 16 or 6A, it's going to gain 2 electrons. So the true formula for oxygen is -2. If it just gained, this one just gained the 1 electron, that would give it, started with 8, it just gained 1, it gave it 9. Okay, so that wasn't it either. Okay, number 19. If a compound forms by ionic bonding, which is not true. So a positively charged atom or a group of atoms attracts negatives. That is true. So that's not it. The net charge is 0. So again, we talked earlier. All ionic compounds form, they'll come together. The ions will stick together until you get a 0 net charge. All the positive and negative charges balance. The compound consists of just 2 atoms, each of opposite charge. Could be. These several ions together, grouped together to form a tightly packed structure. So this is the answer here. This is not it. Ionic compounds can come in multiple arrangements. So it's not just 2. Could be 2 to 3, 1 to 3. Could be anything like that. So 2 to 2. So it's not just 2 atoms. It could consist of more than 2 atoms. 20. The only property listed that is not a characteristic of ionic compounds. So remember, ionic compounds do have a high melting point. They are hard. They are brittle, but they do have a crystal structure. They have a crystal lattice structure. So this is not correct. That's a different bonding structure. 21, the only formula listed below that represents polyatomic. Poly means many. So we want many atoms, and it has to be in ions. So if we look at this, here we have a substance that consists of many atoms, and there's a charge here. So this is both polyatomic and it's an ion. Here's another one. This one also is polyatomic, but here there's no charge. This one has a charge, but it's not polyatomic. Same here. So there's your answer, polyatomic. Ionic bonding always takes place between opposite charge ions. So always takes place between a metal and a non-metal, and they always have opposite charges. 25, ionic compounds conduct electricity in water except when they are solid. So they can't, we talked about that earlier, it can't be a solid state. 24, the melting points of ionic compounds are higher than the melting points of molecular compounds because attractive forces are greater than the attractive forces in the molecule. So C, ionic substances tend to vaporize at room temperature is not correct. Remember, they have a very strong force of attraction, so it takes a lot of energy to vaporize them, to pull them apart. Ionic substances are brittle. That is true, for sure. But it doesn't explain the answer to this question. It doesn't tell you about why the melting points are higher than the other one. 25, an element with which of the following electron configurations is not reactive? It's not. So we're looking for one that ends in a full S and P. So here we have S2P4. So this is not full. This can hold 6. So that's not it. Here we look to the end. We have S2P5. That's not it either. Here, S2P6. That's what we're looking for. This one is not reactive. There's no space there. All elements in group 2 on the periodic table have outermost energy levels with the electron configuration NS2, where N is 1, 2, 3, 4, and so on. Explain how atoms with this electron configuration achieve a stable octet. So here we have S2, but we have P0. If we were to write out the P afterwards, we have 0 in there. So it needs to fill this P in order to get stable, but that's a lot of electrons to gain. So what it does is simply gives away these 2 electrons. So it will lose these 2. 27, the properties of a sodium ion are not like those of a sodium atom, and not quite like those of neon. Explain each of the 2 differences. So if we look at a sodium ion, this is a sodium atom that has lost an electron. This means it has a stable octet. It means it's no longer reactive. Sodium atom is reactive. Sodium ion is not reactive. Neon is a gas. So here the electron configurations of a sodium ion and a neon atom are the same, but they have different numbers of protons. So that changes the properties. Sodium ion is polar, for one, because it's an ion, so it will dissolve in water, it will conduct an electric current. Neon atom, no. So neon atoms don't conduct an electric current, they don't dissolve in water, it's a gas. So there's a problem. Sodium ions will also always come bonded to another element. So there'll be an anion involved as well. Lastly, which group will the alkaline earth metals most likely bond with? So the alkaline earth metals, remember group 2, so they have 2 valence electrons. So they're looking for 6 more. So the best place to find that is group 16. So they have 6 there. So 6 plus 2 gives you 8. So there's our review there.